everyone, welcome in. Ready to dive deep, really deep, into the world of algae.
Algae? Really?
Yeah, you heard right, algae. Not the most glamorous topic, I know,
Right.
but trust me on this one, it's way more interesting than you might think.
Why
We're
that?
going green today, literally. And our guide for this deep dive is a PhD thesis from, get this, 1972.
1972. Going way back.
Right, Harvesting Some Agriculturally Promising Algae, that's the title, by John Benham Gerrish, did his research at Michigan State University.
Okay, so algae research from the 70s. Why are we diving into this?
Because, and this is the cool part, Gerrish was already tackling issues back then that are even bigger now.
Yeah.
Sustainable food, alternative proteins. He was even looking at algae biofuel.
Wow, ahead of his time.
Totally. So let's jump right in. First things first. What exactly are we talking about when we say algae? It's more than just that slimy green stuff in ponds, right?
Oh, so much more. Algae is this whole diverse group of organisms, and it has this incredibly long history as a food source.
Really? I had no idea people were eating algae way back when.
Oh, yeah. Take spirulina, for instance. The Aztecs, those guys were way ahead of the game. They were cultivating and eating spirulina back in the 16th century.
No way. The Aztecs were eating spirulina.
Like, it was nothing.
Yeah.
And then fast forward to the 20th century, spirulina has this huge comeback as a health food.
It's like this ancient superfood rediscovered. Okay, but Gerrish, he was really focused on harvesting algae. Why is it so important?
Because if we're talking about algae as food or fuel, we got to figure out how to get it out of the water efficiently and cheaply.
Makes sense. And Gerrish, he had some strong opinions on this. I remember he even compared one type of algae to crabgrass.
Oh yeah, chlorella. He called it the crabgrass of the lab.
Exactly. So why the crabgrass comparison? What's so tricky about chlorella?
Well, just like crabgrass, it grows easily but isn't very useful. Chlorella is a tiny little algae, and those cells, they just don't want to separate from the water. It's a pain to harvest.
Interesting. So choosing the right algae is key. What else did Gerrish look at?
He looked at a bunch, actually. Coelastrum was one. It forms these little colonies, kind of like microscopic bunches of grapes.
Microscopic grapes. I love it. What about spirulina, the Aztec superfood?
Spirulina. Pictured tiny spiraling filaments, like little green slinkies, all tangled up.
So we've got microscopic grapes and slinkies. Who knew algae could be so visually interesting? And this is just the beginning, folks. Stay tuned because we are about to dive into the nitty-gritty of actually getting these microscopic marvels out of the water and onto our plates, or maybe even into our fuel tanks. So we've got our microscopic grapes and our slinkies. But why aren't we all, snacking on algae burgers yet? What's the holdup?
That's the million-dollar question. And Gerrish, he actually put a number on it. Back in the 70s, he found that harvesting and drying algae, it made up a whopping 75% of the production cost.
75%? You're kidding.
So that's 3/4 of the cost just to get the algae out of the water and dried.
That's insane. So it's like having this super nutritious food, but it costs a fortune just to get it to your plate.
Exactly. And that's why Gerrish was so focused on harvesting. It's the make or break step.
Okay, I'm starting to see why this is such a big deal. So Gerrish, he tested a bunch of different harvesting methods, right? Like a mad scientist in the lab.
He really did. Everything from the super simple to the pretty high tech.
Let's break it down. What was the simplest one?
Sedimentation. Basically just letting gravity do the work. You let the algae settle to the bottom.
Sounds pretty low tech.
It is. And that's the problem. It's slow, and you don't always get the algae super concentrated.
So not very efficient.
Not really. So then you've got your more high-tech methods like centrifugation.
Centrifugation. Okay, now we're talking.
But you're basically spinning the algae really, really fast to separate it from the water.
Like a super-powered salad spinner.
Exactly.
Yeah.
But, and this is always the catch, it takes a lot of energy to spin that fast. So it's a trade-off.
Efficiency versus energy use. It's always something, isn't it?
Always. And then there's filtration. You're basically straining the algae out of the water.
Like microscopic pasta.
Exactly. But some algae are way easier to strain than others.
I can imagine. Did Gerrish ever try anything really out there, like truly bizarre?
Oh yeah, he did. Like using tiny predators to eat the algae and then harvesting the predators.
Wait, what? He wanted to harvest the algae eaters?
It sounds crazy, right? But it shows you how he was thinking. Always trying to find a new angle.
I respect that. Always pushing the boundaries. Did he have any favorites among the methods he tried? Any that really seemed promising?
He had high hopes for electroflocculation. Basically, you use electricity to make the algae clump together.
So you're zapping the algae into submission?
Pretty much. And it worked. But there were diminishing returns. The more energy you put in, the less effective it became.
So it's always this balancing act. You can't escape the laws of physics, I guess.
Nope. He also tried something called electrodecantation. That's where you use an electric field and a filter to separate the algae. And here's where it gets really interesting. He also started looking at how the age of the algae cells affected harvesting.
Hold on. The age of the cells. Like a younger algae is easier to harvest than an older algae.
That's exactly what he found. He even borrowed a term from bacterial research, meaning cell age.
Means cell age. Okay, you're going to have to explain that one.
So it's just the average age of the algae cells in your culture. Like if you took the average age of all the students in a classroom.
Okay, that makes sense. But how do you even figure out the average age of a bunch of microscopic algae?
Good question. And it's something Gerrish was grappling with. He was really ahead of his time in looking at this.
So it's like finding that sweet spot. The algae can't be too young, can't be too old. You've got to harvest them at just the right time.
Exactly. It's like picking fruit. You want to catch it at peak ripeness.
So timing is everything. You've got to strike while the algae is hot, so to speak.
Exactly. And Gerrish, he was really trying to figure out how to measure that, to quantify it. He actually came up with his own measurement. He called it G. It's based on entropy.
Entropy, like how much disorder there is?
Kind of. It's more like how much useful energy are you losing in the harvesting process. A high G means you're wasting a lot of potential, like squeezing an orange and only getting a few drops of juice.
Okay, that's a good analogy. So he was using this G value to compare different harvesting methods?
Exactly. It gave him a way to see which methods were the most efficient, the least wasteful. And that's huge. It's like trying to find the most fuel-efficient car. You need a way to measure it.
I see. It's all about efficiency. Makes sense. Any other big takeaways from Gerrish's research? Anything that really blew your mind?
Well, he started looking at this idea of harnessing the algae's own movement to make harvesting easier.
What? The algae, they move themselves. I thought they were just kind of, floating there.
Well, they do float, but they can also clump together under certain conditions. Gerrish noticed this with spirulina.
Spirulina, those microscopic slinkies are at it again.
Right. And it seems like this clumping, it's triggered by changes in the environment, like a sudden change in light or nutrients.
Fascinating. So the algae are like, hey, things just got real out here. Let's huddle up.
Exactly. It's a survival mechanism. And Gerrish, he saw this as a potential game changer.
Okay, I'm seeing where you're going with this. Instead of forcing the algae to separate, we trick them into doing it themselves.
Exactly. It's like if you want to herd a bunch of cats, sometimes the best way is to just make them think they want to go in a certain direction.
Clever. And imagine if it worked. We could potentially harvest huge amounts of algae with minimal effort. It would revolutionize things. Sustainable food, biofuels, it could be huge.
And that's why this research is so inspiring, even after all these years. It's a reminder that nature often has the answers if we know where to look.
It's like that saying, the best inventions are often inspired by nature. Well, folks, there you have it. Another deep dive into the archives, another fascinating glimpse into the past.
And maybe a glimpse into the future of food and fuel.
Exactly. Who knew that algae, that slimy green stuff, could hold so much potential? Until next time, keep exploring, keep questioning, and keep diving deep.